Hi children, we already studied the four types of chemical reactions. First one, chemical combination. Second one, chemical decomposition. Third one, chemical displacement. And the fourth one, chemical double decomposition. All the chemical reactions fall into one order or the other. Besides these four, we are very much concerned about the gain in terms of oxygen or the loss in terms of oxygen in any chemical reaction. It is known as oxidation or reduction. That is what we will study now. Look here. Oxidation, reduction. When a substance gains oxygen in a chemical reaction, we call it as oxidation. Magnesium burns. It turns into magnesium oxide. Magnesium becomes magnesium oxide. It's a beautiful example of oxidation. See, here we have a reaction. 2Cu, copper, plus O2. Heat the mixture. It becomes 2CuO. This is powder of copper. Powder of copper, you take about 1 gram in a crucible, start heating it. In a crucible, you have taken 1 gram of copper powder and you heat it with a flame. Copper will take oxygen from the air, it burns now, and it turns into copper oxide, CuO. That is when you heat it. Now oxygen is absorbed. Oxygen takes the key role in this reaction. We call it as oxidation. Whereas, if we just move further, same reaction they continue. A step further. That's why I written CuO here. Copper oxide. It is already heated. The powder is hot. The copper powder here, which is brownish, becomes black when you heat. CuO will be black. It has taken in oxygen. The heated copper oxide, it's here. What do? You pass hydrogen over it. You have to produce hydrogen separately through a small pipe or a glass tube. Let it keep coming, and it should be hot. Copper oxide has to be hot. Don't allow it to cool down. Now copper oxide will give up, will lose the oxygen content it has. You just see the reversal of the reaction. The reaction gets reversed. So CuO, copper oxide, when hydrogen gas is passed over it, heated copper oxide, when hydrogen gas is passed over it, it gives out oxygen. It gives up. It loses oxygen that it had, and it again turns back to the copper powder, what you had to begin with. It turns into copper powder. Copper powder. What happens to oxygen? Oxygen combines with hydrogen. You know what would happen? It becomes water molecules. Water molecules get produced. So let me read out the reaction now. Copper oxide plus hydrogen gives copper plus H2O, water. Now let us analyze this reaction. Though I have taken it as an example for reduction. What is the reduction? A substance loses oxygen. Is it so? CuO, it had copper atom and oxygen atom. Copper oxide CuO gives up that oxygen. So copper oxide turns to copper. Now this is reduction reaction. Oxygen is given out. Oxygen is lost. Copper oxide has turned poor with regard to the oxygen content it has. So again it gets back to the brownish copper. Now this part of the reaction you call it as reduction. I put arrow mark here. You can make it out. Copper oxide got reduced to copper. Copper oxide got reduced to copper. In the meanwhile, oxidation too has taken place in this reaction. See here, hydrogen which was made to pass over cupric oxide, copper oxide, it absorbed oxygen from here. Copper oxide lost oxygen. But that oxygen was gained by hydrogen. So from the viewpoint of hydrogen gas here, it is oxidation. It gained oxygen. So what should we call it? We should call it as oxidation. So hydrogen got oxidized into water, H2O. Copper oxide got reduced to copper. A beautiful example here where you see both oxidation and reduction in the same gas. Copper oxide loses oxygen, hydrogen gains oxygen. Now, such reactions you can call them as oxidation reduction reactions. Oxidation, right? Put a hyphen. Reduction reactions. Why do we call so? Because you see both oxidation and reduction in the same reaction. Or there is another abbreviated word. Say redox. We call it as redox reaction. Why redox? RED stands for reduction. RED. OX stands for oxidation. Reduction and oxidation in the same reaction. So you call it as reduction oxidation reaction or call it redox. Redox reaction. So redox reaction is that chemical reaction in which both reduction and oxidation do take place. Let's see some more examples. ZnO plus C gives Zn plus CO. Zinc oxide, Zn is zinc, plus C carbon. I have already introduced this reaction to you earlier. ZnO plus C, ZnO becomes Zn. What do you call this reaction? Oxygen is lost. Oxygen is lost. So this is reduction reaction. Zinc oxide turning into zinc is reduction. Whereas carbon, which gained this oxygen that was released here, it became carbon monoxide. CO, carbon monoxide. So carbon has gained in terms of the oxygen atoms it has taken. So C turning into CO, carbon turning into carbon monoxide, we can call it as oxidation reaction. So in this reaction you have both reduction and you have oxidation. Can we call it redox reaction? Certainly, this is another example for a redox reaction. Mostly wherever there is oxidation in a reaction, subsequently in one part of the reaction there will be reduction. They always go side by side. You study a few more reactions, you will appreciate the facts. MnO2, that is manganese dioxide. Manganese dioxide. Why do we say di? Two oxygen atoms are there, so I call it as dioxide. Manganese dioxide plus 4 HCl, hydrogen chloride. 4 molecules of hydrogen chloride will give you manganese chloride MnCl2 plus 2 molecules of water plus 1 molecule of chlorine. Chlorine is a gas. Here you see MnO2 got reduced to MnCl. It is a reduction. Hydrogen here, it absorbed that O2 and that turned into water. That is an oxidation reaction. So both oxidation and reduction are in the same equation, same reaction. So I can call it a redox reaction. Let's take one more. I told you right at the beginning, magnesium ribbon, when it is burned, it takes in oxygen and it gets oxidized. It gets oxidized, it becomes magnesium oxide. Here you do not have reduction at all. It's a pure, complete oxidation reaction. Magnesium ribbon, I told you, it has to be well polished. The carbonate part which is there as a coat, it is there on magnesium has to be removed and let it burn. Magnesium takes oxygen, it becomes magnesium oxide. It is a clear or a clean example for oxidation reaction. I hope all of you have understood what is oxidation and what is reduction and the meaning of redox reactions. In a chemical reaction, if oxygen is taken in, oxygen is absorbed, oxygen is gained, oxygen takes key role in the reaction and substances they absorb in oxygen and get bonded with oxygen. You call the reaction as oxidation. If oxygen is lost by chemicals, you call it as reduction. We will move on to another part now. This too is a reaction that keeps taking place in a lot of metals around us. It's a slow reaction. A slow reaction. We call it as corrosion. You have iron bars which are fixed to a window. If you don't paint the iron bars, within days or within months, all the iron bars, they get a coating of rust. If you take a white piece of cloth and go on rubbing the rod, your handkerchief or cloth will become black in color. What is that because of? That's because of the rust. Iron has got rusted. Iron acted with oxygen in the air in the presence of moisture and iron has turned into iron oxide, which you call as rust. Now such a reaction where iron gets rusted, you call it as corrosion. Any gadget that is made of iron, say iron railings, the body of a car, the body of a machine made of iron, or any of the appliances made of iron, they all, you see, they don't last long. They start getting rusted. They absorb oxygen, they get bonded with oxygen, iron will turn into iron oxide, and what is the ultimate result? Iron oxide, you call it as rust. See here, shiny iron articles. When you bring a new iron article, it will be shiny. You don't find any fault with iron at all. It gets coated. Iron articles get coated with reddish brown powder. Rust is reddish brown powder or maybe black even. If a number of months pass on, it will turn to black. Reddish brown powder after some time. After some time. That's why you get it painted. A new window, if you have got fixed in your house, immediately after it's fixed, you get it polished with sandpaper, clean it well, and you paint it to somehow prevent iron getting rusted. So this is called as rusting of iron. Here you have even a definition to explain what is rusting of iron. We call it as tukku hidiyudu. Rust is tukku. Rusting of iron. Kabbinakke tukku hidiyudu. We will come to the next. Is it the only metal? Iron is the only metal which gets rusted? No. You see, copper too gets rusted. Silver too gets rusted. How? Usually we don't say rusted, we say corroded. Silver articles, if you keep wearing for a long time, unlike gold, silver loses its shine. It turns almost towards black. Again, you have to polish it, clean it, and certain chemicals are also available in the market. You get them applied, and once you treat well, they start shining again. You remember? All silver articles are like that. They need to be treated with those special chemicals available in the market. To give back that shine to silver, you use that. Even as regards copper, it's the same thing. Copper and silver too corrode. A simple word for corrosion is rusting. They too get rusted. Rusted in itself, they lose their shine, they lose their beauty. Okay. Corrosion results when metals are attacked by moisture and acids. In the atmosphere, the acidic content which is there in the air and water content, they make iron get corroded easily. You see, mostly all the iron objects, they get rusted very fast in the rainy season. One rain is enough. One treat with water is enough, iron starts getting rusted if it has not been properly painted. You leave some iron objects in the open. It rains. Leave it there for 2 or 3 days. Over those 2 or 3 days, iron would have lost all its shine by moisture and acids. Moisture and acids make iron get corroded. Let us come across another term, almost on the lines of corrosion. Rancidity. Rancidity we call it as. See, when you have got some dishes prepared using fats or oil and fats. Not of dishes prepared out of oil and fats, they are very tasty, very tasty. But leave them aside for a few days, 3 days, 4 days or 5 days. On the 4th or 5th day, they start smelling. You taste them, you don't feel like enjoying them. Ultimately, you may have to throw them even, throw them out. All the sweets that are prepared using fats and oil, they all may get spoiled after the 3rd, 4th or 5th day. So people after 2-3 days, they keep a small piece in the mouth and taste it, find out whether it has retained its sweet taste or not. If you feel it's spoiled, you have to just throw it. You can't keep it for long. See here, when fats and oils get oxidized, this is also oxidation. They get oxidized, they become rancid. These sweets have turned rancid. They have become rancid. That's why you can't eat. So what do we do in the house usually all these years? We used to keep them in airtight containers. You might have seen your mother or grandmother, or people in the house who are in charge of these things. They put them in a well-washed, dried container, put them carefully inside, not with wet hands again. Your hands should be dry. Even that moisture is enough to spoil them. So put them one by one, and afterwards you put the lid in such a way it should be very tight, airtight. Then at least for some 5-6 days you can keep, because oxidation will not take place in full swing. Because the air which is there inside the container doesn't have the needed quantum of oxygen. There is no supply of oxygen for things to get spoiled. So always it's said, when you want to preserve oily things, oily items, then you have to put them in airtight containers and put the lid very, very tight. So that's one way. Otherwise, to prevent, we use even antioxidants. Antioxidants are available in the market. We can add a little bit of antioxidant and prevent oxidation. That's another way. Now, keeping food in airtight containers reduces rancidity. Food will not get spoiled soon. You should not leave it in the open. Okay. Now, the latest method, it's a very recent method. Maybe from last 10 years or 15 years it has come into operation. What is it? Chip manufacturers or companies that prepare chips, they put them in packets and fill the packet ultimately with nitrogen and get them sealed. Other than chips, what you have inside the packet is only nitrogen. Nitrogen is not at all helpful in oxidation. For oxidation, which is the gas we require? Oxygen. There is no oxygen, all the air is removed from the packet, that plastic or polythene packet. You have filled it with nitrogen and have got sealed. Now you can keep the items even for 6 months. 6 months. Chips will not get spoiled. Otherwise, 7 or 10 days are enough. Even if you have prepared chips in your own house, they get spoiled. You will not be able to use after 7 or 8 days. They will be smelling bad. So see here, bags of chips are flushed. You know what's flushing? Toilets are flushed. After the toilet is used, you flush it, because any content of the gas or the liquid which is there, maybe urine or anything, you have to flush it and see that it's clean. Bags of chips are flushed with nitrogen. Remember the gas. Nitrogen to prevent oxidation. Even the exams, it's a usual question that's asked. How are chips preserved for a longer period? By flushing them with nitrogen and sealing them in an environment of nitrogen, you can keep them for a longer time. So with this, the entire chapter, chemical reactions and equations, it's over. Go through the text, read it a number of times, go by the notes that I have given as the work here for explanation. Keep this also as one of your necessary helping part, read the text well, underline the parts which you come across there in the textbook, and key aspects what I have stressed in the lesson, try to keep them in mind. Learn how to balance the equations, and equations which are in words, you should be able to translate them into equations where you use all chemical terms and balance it out. These are the important aspects in this first chapter. Thank you.